Econ students, what is going on today? Well, today we are going to learn about elasticity. E to the L to the ticity. Here we go. So we're going to talk about elasticity of demand today. And this is what you're going to learn about. You're going to learn what elasticity is, the difference between inelastic and elastic demand, how we're going to solve that given a set of problems. And you're also going to be able to use this to determine if goods and services are luxuries or necessities, complements, or substitutes. So let's get into it today. You're going to be doing some basic multiplication and division. And another thing you're going to learn today, which will really help you in life, is you're going to learn how to determine a percentage change. If you haven't learned that already, congratulations, you're going to learn that today. So let's get into it right here. Slide 47, here we go. So elasticity is used to help to determine how responsive consumers are to a change in price. So if you were a supermarket or a car repair shop or an auto dealership, or you were selling iPhones and you were meeting with your sales associates and you're like, you know what, I really want to raise my prices. I want to raise my prices by 2%. You would want to figure out before you do that, can you do that? Meaning, if you were to raise your prices 2%, are people still going to buy enough of whatever it is you're selling so that you make revenue, make money? Because there are some goods and services that if you were to raise the price, it's probably not a good idea because people aren't going to buy enough of it when you raise the price, and you're going to lose money when you raise that price. But there's other things that people really need, or people are going to be like, screw it, I'm still going to buy it even if you raise the price. Then you should do it. Elasticity shows us that. So, bottom line, elasticity shows how responsive people are, consumers, to a change in price. So that's what we're going to look at today. And I give you the example there with the price of pens. If you were Bic pens and you want to raise the price of Bic pens from $1.50 to $1.75, if the demand would increase or decrease, we're going to learn about how to calculate that, all right? How to quantify it. So there's steps. Think back to when we talked about supply and demand with graphing supply and demand. I broke it into 3 steps. You could do the same thing here. Break it into a few steps. So step 1, this is important. You have to determine the percentage change in the price of the good and the service, and you have to determine the percentage change in demand, okay? So if you look at step 1, part C right here, this is important. I'm going to highlight this. This is your percentage change formula. So to find a percentage change, you take the change over the original times 100. So let me show you what I'm talking about here. If you wanted to find the percentage change in the price of pens, let me ask you right now, how much did the price of pens increase by? Well, the price of pens increased by 25%. So you would take 0.25 and divide it by the original price of the pen. So what's the original price? $1.50. So if you did 0.25 divided by 1.5 times 100, because you got to do that to put it into a percentage, you would get the percentage change in the price of pens. That is step 1. So let me go back to step 1 here. Part C. Percentage change is change over original times 100. That's an important equation formula that you need to know. Step 2. You take that percentage change. You take the percentage change in demand and divide it by the percentage change in price. So you're finding 2 percentage changes here, guys. You're finding the percentage change in pens, or you're finding the percentage change in price, and you're finding the percentage change in demand. An example will help. I'm going to show you the example more in a second. And you divide those two. And then, if you get a number that is less than 1, demand is inelastic. If you get a number that's greater than 1, demand is elastic. And if you get a number that's exactly 1, demand is what's called unit elastic. So more on that in a second. So try this out. The price of water bottles. So let's say Aquafina is looking to raise their price of water bottles from $1 to $1.50. The quantity demand, when they do that, the quantity demanded for Aquafina water bottles decreases from 150 per week to 125 per week. So determine the percentage change in price and quantity demanded. Then determine the elasticity. And if the demand for water bottles is elastic, inelastic, or unit elastic. So think back to these steps here. Go through your steps and see if you can figure out this problem. Pause the video, do the math, and I'll show you the answer on the next slide. Okay, so if you did the math correctly, here's your work. The percentage change in price. Price went up by 50 cents, so that's your change, 0.50, divided by the original price of $1, 0.5, divided by 1, 50%. So the percentage change in the price of Aquafina water bottles was 50%. That's pretty high. Then we got to find the percentage change in demand. Well, demand fell from 150 a week to 125 a week. So demand fell by 25 water bottles. So you would take 25 divided by the original amount. The original amount right here, 150, and you get 16.67%. So demand fell by roughly 17%. Now you might be wondering right here, stop it for a second. Why isn't this negative? Because isn't this decreasing by 25? It is, but you use absolute value here. Why? Because the law of demand is in of itself negative. It's a negative relationship. So you're always going to get a negative number. So bottom line here, you don't have to use negatives. You use absolute value here. Because when the price increases, the demand is going to fall. It's going to be a negative relationship all the time. When the price falls, demand increases. Okay? So absolute values here. So now you got your percentage changes. When the price of water bottles goes up by 50%, the demand for water bottles falls by 17%. Take your change in demand, divided by your change in price, percentage change in demand divided by your percentage change in price, and you get this, 0.33. Oh, I'm on the clock. Who should I draft, guys? Let's see. Really quick, this is towards the end of my fantasy football draft. Let's see. I want to get a quarterback. Boy, I don't know. Let's go with this guy. All right. I'm going to go on auto draft here because it's towards the end of the draft. All right. Okay, so the 0.33 means that the demand for these water bottles is inelastic. It's inelastic. So first, what does the 0.33 represent? So what this means is that for every 1% increase in price, demand for this product falls by 1/3%. So I'll say that one more time. For every 1% increase in price, demand falls by 1/3, 0.33%. And then the demand for this product is inelastic. So now you might be thinking, what does inelastic mean? This is good news if you were a company, if you were a firm, if you're Aquafina water bottles, because what this is telling you is that you could raise your price of water bottles by 50%. And if you were to do this, the demand for your product is only going to fall by roughly 16%. This is good news for you. This means you're going to make more money. So when demand for your product is inelastic, that's good news for the seller. It's good news for the seller. Demand is inelastic. It's not really going to change. It's not very flexible or responsive to a change in price. Okay? See if you can match these up. Pause the video. See if you can match these up. Okay, so if you tried this out, unit elastic. This is where you get a number that's 1. It's exactly 1, meaning that for every 1% increase in price, demand falls by exactly 1%. The ratio is exact, it's even. So number 1 would be B. Number 1 would be B. The percentage change in demand is equal to the percentage change in price. Elastic demand. What elastic demand means, number 2, is that demand for your product is very responsive. It's very flexible. If you were to raise your price by 4%, people are going to buy it by 6 or 7% less. People are very responsive. They're going to find something else to buy instead. So what that means is C. Number 2 is C. The percentage change in price is less than the percentage change in demand. So if you want to put it into examples here in numbers, say you raise your price by 1%, elastic demand would be like 1% increase in price then leads to a 3% change in demand. So that's not good. If you sold something in which demand was elastic, that means people have a lot of substitutes, they got a lot of other choices, and if you were to raise your price, probably isn't going to work out too well for you. You're going to lose a lot of customers. Okay, so 1, B, 2, C, 3, that is A. The percentage change in price is greater than percentage change in demand. You know, you raise your price by 6%, people only buy 2% less of it. That's awesome. You're going to make more money. You should raise your price. People don't have a lot of other choice. Okay, so inelastic, inflexible, not very responsive. Elastic demand, very responsive, very flexible. People are shocked. They choose something else. Unit elastic, you raise your price by 2%, people buy 2% less. It's exactly equal to 1. Ratio is 1. Okay? Try these out. We're going to deal with soup here. Let's do Campbell's soup. Campbell's soup decides to increase the price of their can of soup from 80 cents to $1. The quantity demand for soup then decreases from 250 to 225. So you got to find A, the percentage change in demand and price, B, the elasticity, and then C, determine if demand is elastic, inelastic, or unit elastic. Pause the video, see if you can get this done. I have faith in you. Go. All right. Let's check it out. Part A, the percentage change in price. Okay, so the price of soup increased by 20%, 80 cents to $1. 20 cents divided by the original price of 80 cents means that the price of Campbell's soup went up by 25%. Second part of A, you got to find the percentage change in demand. So demand fell by 25 units of soup. The original demand was 250, so that means that your percentage change in demand fell by 10%. So you got a 25% increase in price and a 10% change in demand. So right there, if you look at these two, which one's greater, guys? It's the percentage change in price. So knowing that without even doing the math, is this going to be elastic or inelastic? Don't even look at D. Take your eyes off D. It's going to be inelastic because the percentage change in price, look back at your matching. The percentage change in price is greater than the percentage change in demand. Isn't that true here? Look at this. 25 is greater than 10, right? This is great for Campbell's. Campbell's should jack up the price of their chicken noodle soup and their tomato soup because you get 0.4, which is inelastic demand. Any number less than 1 refers to inelastic demand. What that means, what this 0.4 means, if Campbell's was to raise the price of their soup by 1%, demand for their soup would fall by 0.4%. Great news for Mr. Campbell's and their chunky soup. So you get inelastic demand here. Try one more. Now we're dealing with Twix bars. Twix bars goes from $1.10 to $1.25. Quantity demanded decreases from 90 to 60. People got Snickers and M&Ms and all that other good stuff. Same process. Follow your steps. Do your calculations. Pause the video. Last one. Finish strong here. All right. Let's check it out. Okay, so you got part A would be the change in price. 14% change in price. Okay. $1.10 minus $1.25 is 15%. Or I'm sorry, not 15%, but 15 cents divided by the original price of $1.10. You get a 14% change in price or increase in price. Now, people buy 30 units less. They're going from 90 to 60. The original units were 90. You got a 33% decrease in demand. 33% decrease in demand divided by a 14% price increase, you got 2.35. This is terrible news for Twix. Must be a lot of substitutes, a lot of choice in this market for people because demand is really elastic. So is this good news for them? Should they raise their price? No, they shouldn't because they're going to be losing some big time money because people are going to go buy other candy bars from other competitors. And that, ladies and gentlemen, is your video tutorial on elasticity. So let's go back real quick. Make sure you can do these things. Make sure you can define elasticity, how flexible or responsive people are to a change in price. Tell me the difference between elasticity and inelasticity, and then use the formula given a set of practice problems to determine elasticity. One other thing I will mention here, this is important. You can use percentage changes not only with elasticity, but with trying to figure out how much more money you made from 2019 to 2020, how much more in taxes you might have paid. If you're looking for a pay increase, you can use this. Your change in pay divided by your original pay times 100. Percentage changes come in handy for a lot of different things. They serve a lot of different purposes. So this is something that you can use again and again, not only in economics, but in your own personal life. So that's very important. Make sure you keep in mind this basic equation to find a percentage change. And with that, you guys are done for the day. When we come back, we're going to go over this. We'll go over cross price and income elasticity. So hope you enjoy the video today. Try out those practice problems that I assigned in Canvas, and we will talk to you soon.